Good morning from California. This is Dr. Satish Singhal, PhD, Computer Science Department, El Camino College, California. I want to talk about one important part of object-oriented programming called object construction, and people have problem with this sometime. I teach C++, but the kind of system I want to show today does not exist for C++. I want to use animation in one of the Java program, but principles are exactly identical. I'm going to point out changes that you would make in the Java program to make or to write a similar class in C++. Okay, so the way I want to show you is there's this software called Jeliot, really runs for Java only, but we can learn a lot about object-oriented programming in C++ using this device here. So as you know, I've written a class called employee, and in Java you assign private versus public to each member separately. In C++, this private will be placed somewhere here, actually here, and then every member underneath that would be uh, considered private. Okay, but that's a small technicality. We're not going to worry about that. So since label private is assigned for employee class for the last name, first name, hours worked, and pay rate and salary, all those data are private. And then we have public members. This is the explicit constructor, and it takes argument for all the members, like last name is initialized to L name, like here. Takes an argument for the first name, so first name is initialized to F name argument, and hours worked member is initialized to argument HRS passed to the constructor, and pay rate member is initialized to the rate argument of the constructor. But salary calculation requires some formula. We don't expect user to do it. After all, we are writing the software. User should not have to do too many calculations. So there is a function called get salary, and I believe even if I didn't write the public, it may or may not have worked. So let's put down the word public. It is after all public. I would have run into trouble later if I didn't have that. So hold on a second, where are we? Okay. So get salary function initializes the salary after doing the calculation. It returns a double type uh, for the salary. Okay. So here we apply salary calculation rules. If hours worked is less than 40, then salary is straightforward multiplication of hours worked and the pay rate. And notice hours worked and pay rate were already initialized at the constructor here. Later on in the second part of this video, when I run the theater, you will see these initializations very clearly. Okay. But get salary function is called to initialize the salary data member, which is computed, which is not passed to the constructor because we don't want user to do calculations for it. Okay. So this wiring, hard wiring of one piece of code to another is very common in object-oriented programming, as it is in the regular programming actually. So get salary functions here is wired to compute the salary, and it can do its job because hours worked were already initialized to hours, and pay rate was already initialized to rate. That's why it can work actually. So if hour works is less than or equal to 40, then straightforward calculation, hour work and pay rate is salary, and that gets returned later. Otherwise, hours is going to exceed 40. So first 40 hour is the straight 40 into pay rate, really exact same formula as here, except hour works is 40 regular hours. But anything above 40 has to be paid at a 1.5 times of the pay rate, and we do that here. We compute extra hours above 40, multiply that by 1.5, multiply by pay rate, and once this if and else finish execution, the salary is computed and we return it. And then at that time, get salary will set the salary data member. And once again, you'll see when we animate this whole code in this theater, you'll see that. That will be in the second part of the video. This video probably won't be very long because of that. Okay, so now how do we make use of it? In C++, you'll just have a function main, but in Java, there's extra formalities required, another class is required, and so on. But that really doesn't matter. All I want you to focus is on this piece of code where, using Java syntax, this employee E has been constructed by calling the employee class constructor. This word new will be used even in C++ a little bit later, but for now just ignore the word new, just focus on employee class constructor being called and the name, last name, first name, hours worked, and pay rate data has been passed. So when this line 30 to 32 are executed, basically you're shifting the code control to this constructor here. So I'm not able to see both of them at the same time, but in the theater you will see, oh, maybe I could try. Actually, it's not going to work. Okay, or maybe I can just shift it just a little bit. Yeah, maybe I can shift it just a little bit. Okay, so there you go. And for the time being, I may have to shift it back again later when I do the theater. Okay, so you can see that when employee class constructor is called, John will be submitted to L name. Sorry, Doe will be submitted to L name. John will be submitted to F name. Hours will have copy of 45, and rate will have copy of 10, passed by value mechanism. Okay. And then line 12 sets up the last name to L name, which was Doe. First name is set to F name, which was John. Hours works is set to HRS, which was 45, and pay rate is set to rate, which was 10. And then get salary function is called, and get salary function already has these arguments because all class data members are visible to all the member functions. So hours worked is already set, which will be 45, but 45 less than 40 is not true, so if will not be done, else will be done. So since pay rate is 10, first part will give us 400, and then extra 5 hours, 10 into 1.5 is 15, so 5 hours at the rate of 15, that will be 75, so total salary will be 475. Okay. And then salary member will be set accordingly. Okay, so I'm going to leave this video here because I want to animate the whole code using this theater and the call tree, and there will be some question and answers as well, and I'll come back to this code again at that time, although in a little different way. I may have to shorten this window quite a bit, but basically by the time the line 30 is done, my object would have been constructed with last name being Doe, first name being John, hours worked 45, pay rate 10, and salary calculated by this else block, uh, which will be 475. So notice that's how we wire things together. Wiring of E is done by constructor first, passing the arguments here, and then salary needed to be calculated separately. So wiring of salary is done by calling the get salary function, which is here. It's a computed data member. So classes can have computed and initialized data member. Okay. So I'm hoping that this had some foundation in terms of how constructors work and how constructors can call other functions to compute data members that are not directly initialized by the data input from the user. Okay. Next, we're just gonna make a theater of this process, and hopefully whatever lingering questions are there, that would be answered at that time. So again, this is object-oriented programming, object construction 1 by Dr. Satish Singhal, PhD, Computer Science, El Camino College, California. Thank you. I'll be back in video 2 very shortly.